In this video, we'll talk about finding the derivative of the other trigonometric functions. So the rest of the trigonometric functions we have, tangent, secant, cosecant, cotangent, are all built on sine and cosine, which means since we have the quotient rule and we know the derivative of sine and cosine, we can put together what these derivatives should be. For instance, let's look at tangent. If I want to differentiate tangent of x, I can rewrite this as the derivative of sine of x over cosine of x. Now I can apply the quotient rule to this function. This derivative is cosine of x times the derivative of sine minus sine of x times the derivative of cosine all over cosine of x squared. And then we can plug in our known derivatives for sine and cosine. The derivative of sine is cosine, meaning that first term becomes a cosine of x squared minus sine of x times derivative of cosine, but that's minus sine, so I'll get a plus sign here and a sine of x squared over cosine of x squared. Or otherwise you've seen this written are probably cosine squared of x plus sine squared of x all over cosine squared of x. And what's that numerator? That numerator is cosine squared of x plus sine squared of x. That's always 1. So this is a 1 over cosine squared of x, which I can rewrite as a secant squared of x because secant is 1 over cosine, and that's my derivative. So from this work, I get that the derivative of tangent of x is secant squared of x. I can work out the same process for the other 3 trigonometric functions to build the following table. The derivative of tangent is secant squared, like we saw before. The derivative of secant is secant x times tangent x. The derivative of cotangent is negative cosecant squared of x. And the derivative of cosecant of x is negative cosecant of x cotangent of x. You can do all these by quotient rule, just like we did the tangent rule one. They all work in the same way. You're going to probably need to use the fact that sine squared plus cosine squared is 1 at some point, but they simplify out in the same way to give you exactly this for your derivatives here. And we can again apply these formulas with things like product rule and quotient rule and all those things to get other derivatives. So when I differentiate e to the x times cotangent of x, this is a product rule. So what do I get? I get that my derivative should be e to the x times the derivative of cotangent plus the derivative of e to the x times cotangent. This gives me an e to the x. The derivative of cotangent is negative cosecant squared plus derivative of e to the x is still e to the x. Or if I want to simplify this out some more, e to the x cotangent of x minus cosecant squared of x. That would be the answer there. This is how you can use the fact that you know the derivative for sine and cosine combined with product rules and quotient rules to figure out the derivatives for the other 4 trigonometric functions and then use them in combination with other rules again to differentiate more complicated functions.